Good morning, honoured guests. Thank you very much for your kind invitation to speak at the Designing Future Textile International Symposium here at the Mills Fabrica, this wonderful space for textile innovation. As design-led innovation is increasingly recognised as a way for advanced knowledge economies to develop, with the creative industries and the economy working together towards public good, my theme today is to speak about useful innovation. And this first example by Barbara Payno is called Can We Wear Our Home? This is an urban nomad home kit. It's a useful innovation meeting human need, inspired by the European migration crisis, in which a wearable shelter transforms from coat to tent, with this innovation being put into production to help those most in need. What are some of the conditions for generating useful innovation? It could be suggested that factors include an appropriate and supportive environment that nurtures design-led innovations, the necessary strategies, talent, structures, and partnerships needed to foster innovation. The importance of placing design not at the end, but at the forefront of the innovation process. And the realization that design is best placed to ask the human-centered questions that technology will help to solve, leading to more useful innovation and greater benefit for society and for the quality of life. And as home to one of the UK's most successful university-owned incubators, Innovation RCA, the Royal College of Art plays a significant role in providing the environment and developing the talent that has led to any number of useful innovations addressing real-world need, and which I shall refer to in this talk. Considering human-centered questions, design-led innovation can create different and sometimes more useful solutions than more traditional approaches to innovation, which tend to work from discovery or invention to application. On the other hand, crudely put, we start with the problem from the user perspective, and we work backwards towards invention. This methodology acknowledges human needs, fears, aspirations, and ensures that the solutions developed take account of these, especially where these might contradict conventional wisdom. This approach to innovation designs solutions for real people, rather than for a notional standard human being. This is what we call inclusive design, ensuring that solutions don't exclude people with differences from the notional standard caused by age, physical ability or disability, and mental health. So we could say that design-led innovation aims first to identify the problem, dissect and understand it better, and then develop the best solutions to improve lives and user experiences. For example, when you've been considering user need in the creation of the first successful patentable folding bicycle wheel, as James Dyson Innovation Fellow Duncan Fitzsimmons did here at the RCA, how do you develop your innovation and bring the greatest benefit that makes a real difference? You think laterally, of course, and develop your invention as a folding wheelchair wheel, allowing disabled people to take their wheelchairs onto aircraft and other inaccessible places. And these patent-pending foldable wheels are full-sized wheels that can be used on bicycles or wheelchairs and can be folded down to a convenient size for transport and storage. And these are now licensed and being marketed in the USA as Morph. TGO was founded in 2015 by RCA graduate Ming Kong, one of the first ever Royal Academy of Engineering Fellows. And it offers a new sensing and control method using a soft, hypersensitive material that can create a greater range of touch motions than traditional electronic devices. It can also be molded out of one material into a 3D shape rather than assembled in parts. TGO could replace conventional controls, such as the trackpad, the car dashboard, and even gaming handhelds with a sculptural all-in-one 3D sensing material. And this has now secured contracts from major brands in the automotive and consumer electronics sectors. The human-centered need in Luwatt is obvious, powerful, and on a globally useful scale, providing an off-grid sanitation and power system that combines waterless toilets with an anaerobic digester to deliver hygienic and odorless management of waste, allied to the production of bottled gas for heating and cooking. Founded by RCA alumna Virginia Gardner, Luwatt creates local economies around waste treatment by converting human waste into natural gas and fertilizer, and is deployed in sub-Saharan Africa thanks to grants from the Gates Foundation. The system takes the waste to an anaerobic digester, which then transforms the waste into methane gas, which is bottled to be used for power or electricity generation. And it first came about as part of a master's project at the RCA, with its team now comprising designers, engineers, business people, all of whom are committed to creating a paradigm shift in sanitation. The number of wild pollinators, especially bees, is steadily declining globally due to industrial agriculture, pathogens, loss of biodiversity, use of pesticides, and climate change. This documented decline poses a significant risk to the production of many crops, and it threatens global food security. How do you use design to address this? The answer is that Alombria encourages flies to be more efficient pollinators in scenarios where bees are no longer as viable. It uses chemical volatiles to manage pollinating fly species, thereby increasing crop productivity and ensuring sustainable food harvests for the future. Another innovation, inspiring in both its simplicity and concept and breadth of application, concrete canvas is made from rolls of material impregnated with concrete and activated with water. This outstanding innovation allows shelters to be created in disaster zones and for irrigation channels to be created quickly to transport water to where it is needed. A more sustainable way of using concrete, it comes in rolls and can be speedily laid up to 10 times faster than conventional concrete. Not only does it cut down on construction time and cost, it also has a low-mass, low-carbon technology that uses 95% less material than traditional methods. Its greatest application has been in the construction industry, where it saves time and money over conventional approaches, and is now exported to more than 80 countries around the world. Let's place design at the forefront of the innovation process. What benefits arise by placing design and human-centered approaches at the start or center of the process, and for creative insights, human need, and design thinking to drive technological and scientific development, rather than merely adapting it for commercialization? The business partners the RCA collaborates with appreciate that by approaching their challenges from a design-led, human-centered position, they differentiate themselves from their competitors in the market. The products and outcomes of this approach can ensure a more rapid route to market, as the risk of developing products and services that work in theory but don't meet user need is reduced if their perspective is built in from the outset of the project. In this spirit, the RCA's Intelligent Mobility Design Center has shifted research from the design of vehicles to questions of mobility and mass movement within a complex and changing urban and global environment. And this example here, the Greenwich Automated Transport Environment, is an £8 million Innovate UK funded project that saw a fleet of driverless pods providing a shuttle service around the Greenwich Peninsula in London, in order to understand public acceptance and attitudes towards driverless vehicles. And what makes it truly unique is its focus on people. Here, Dr. Sina Sare, an academic leader in robotics for the RCA and holder of a prestigious £400,000 UKRI Innovation Fellowship, focuses on developing advanced robotic anchoring mechanisms. The research is inspired by the versatility of the octopus and the octopus's suckers, which can be used to grip clean or dirty surfaces in air or underwater, and is invaluable for a wide range of industrial, medical, and other applications. These might include attachments by climbing robots for inspection and maintenance of buildings, including heritage locations, power plants, steel bridges, and disaster zones. Perching by flying robots that can provide a bird's eye view of an area of interest or object manipulation. Derived from Dr. Roland Lamb's dual expertise as a designer and a jazz musician, and developed through his doctoral studies at the RCA, Seaboard is a radically new musical instrument based on the design of a piano keyboard, but it brings together a traditional approach to making music with cutting-edge digital technology in a way that is so intuitive and tactile that you can play it with your eyes closed. This approach enables performers, composers, and producers to exert unprecedented real-time control of all the major characteristics of sound: volume, pitch, and timbre. If you can play the piano, you already know how to play the Seaboard, and it literally puts a new world of expressive possibilities right at your fingertips. And if you're a fan of musicals, you will have seen this in the film La La Land. Did you know that printed circuit boards make up 8% of the 50 million tons of electronic waste generated every year? Geva produces biodegradable PCB laminates called Soluboard to replace the non-recyclable substrate that is currently used. Currently, the only way to recycle metals from PCBs is to shred and burn them, which creates harmful emissions. With Soluboard, the PCB is disassembled using warm water, which allows recovery of the quality and precious metals for reuse. It's a harmless process, and it's being trialed by a very well-known white goods manufacturer. Amphibio is developing artificial gills to allow divers to dive underwater for significantly longer periods of time without the need for heavy gas tanks. This Amphibio 3D printed gill has been demonstrated to a depth of 10 meters, and its founder is an RCA graduate who's attracted initial investment of £100,000 to advance the development and testing of this early stage technology. Pinatex is a new sustainable alternative to leather, which is made, believe it or not, from natural fibers extracted from the waste leaves of pineapple plants. And the CEO, Carmen Hijosa, won Innovate UK's Women in Innovation Award 2016, and this is the first fabric to receive a PETA-approved vegan logo. As a society, we consume a large amount of poultry, and the resulting chicken feathers are a significant waste issue for industry. 10,000 tons of waste feathers are produced every day globally. AeroPowder here has developed a process for turning surplus feathers into insulating materials. The first product is thermal packaging Plumo, which is being used to protect cold food shipments and is fully recyclable. This company has won many awards, including its founder winning the Innovate UK Women in Innovation Awards and the Mayor of London's Low Carbon Entrepreneur Award. Squeeze was invented by 4 designers and engineers while students at the RCA. Their inspiration for Squeeze started with a teenager with autism. The team found that many people responded well to firm, hug-like pressure when feeling stressed or overloaded with sensory information. But whilst they liked to be held firmly, they often disliked physical contact. With all this in mind, the Squeeze hugging vest was born. And there was an overwhelmingly positive reaction to the first pressure vest they produced, which is now sold internationally. So there are so many wonderful innovations, but how do you create the environment for them to be born and to flourish? Design is ahead of the game in some ways, in that it frequently has an applied, practical, and project-based focus, which ensures that the benefits and outcomes are in the real world. This creates opportunities for projects to be undertaken in collaboration with partner organizations and is key to stimulating an environment in which design-led innovation can flourish. It takes time to build up expertise in managing and delivering successful projects, and to build up a reputation that attracts high-caliber, serious partners from business, industry, government, and the public sectors. And in addition to high-quality design researchers and students, this involves a professional support team leading business development and project management, which is important to minimize the gap between academic ways of looking and working and rapid business development timescales. And it's essential to ensure that there is a network that maintains connectivity to the outside world. To support and enable design-led innovation, Innovation RCA is the Royal College of Art's Centre for Enterprise, Entrepreneurship and IP Commercialisation, and is one of the UK's most successful incubators, according to a UK government report. It provides a design startup incubator and a creative brands accelerator, with 82 graduates having launched some 56 startups, with an astonishing 87% survival rate after 5 years, where the university average is around 16%. This has created over £29 million in turnover last year and winning £9 million of competitive R&D funding, and is the most successful incubator of its type in the UK. And to build on this success and double the number of startups, Innovation RCA will move in 2 years' time to this new research tower, which is part of a new campus for the RCA being built by Pritzker Prize winners and architects Herzog and de Meuron. And this is being funded by the UK government in recognition and to support design-led innovation. This RCA collaboration wheel illustrates how we can introduce a partnership with a company on any one of a range of levels and types of engagement, from rapid design sprint models to studio projects working with RCA postgraduate students, through to consultancy to longer-term industry-funded research collaborations. And how can we develop the talent, strategies, and partnerships that are needed for successful innovation? We link teaching, research, and external engagement and enterprise. Where possible, we develop partnerships with business and industry that involve projects for students, as well as larger scale collaborations for staff. And attract talent because of the reputation for high-quality research, high-quality teaching, and a strong reputation for collaboration with business and industry partners. So, what happens when a computer scientist works with a designer and a surgeon? The answer, of course, is Helix, the Healthcare Innovation Exchange, a collaboration between RCA designers and Imperial College London's Institute of Global Health Innovation. The centre is a partnership with Imperial College's St Mary's Hospital, and it brings together design researchers with clinical staff to tackle the big demands in healthcare today. It's the first example of a design studio in a working teaching hospital. What it produces are things like this. It's an asthma management device. 75% of hospital admissions due to asthma are avoidable, and 90% of asthma deaths are preventable. So by bringing design together with medicine, we're able to produce devices which enable prevention at a much earlier stage. And the aim of this project is to focus on the needs of young children, using tools to avoid the need for admittance to hospital. Also, in areas like stroke rehabilitation, working with patients, clinicians, healthcare workers, and hospital administrators, the team of designers and surgeons work collaboratively on areas including stroke rehabilitation with remarkable results, improving patient recovery from stroke through design. It also helps if design-led innovation can gain not only traction through design with business, but can also lead the way at the highest level. Here, the RCA was invited to the Prime Minister's Senior Technology Advisor to deliver a summit at number 10 Downing Street to help senior policy advisors and civil servants across Whitehall discover new ways to make government services better. And this is a great example of design thinking leading to innovation at the highest level. Here, the RCA runs custom executive education workshops for businesses such as Fujitsu, Panasonic, JP Morgan, and Majid Al Futtaim, one of the largest multinationals in the Gulf region. Here, a 4-month-long innovation challenge was designed for the Kuwait Foundation for the Advancement of Science. And this involves helping 10 of the biggest companies in Kuwait to develop creative leadership, design thinking, and providing online coaching alongside a London innovation visit. Working directly with industry, the RCA was able to partner with its students with Airbus to help ideas and concepts for a future aircraft cabin for 2030. And also inspires consultancy projects, including a hackathon with Fujitsu to achieve working demonstrations of technology concepts and prototyping. Innovation-focused international partnerships include our Tokyo Design Lab, a collaboration between the RCA and the University of Tokyo, which brings together designers, scientists, and engineers to develop meaningful and deployable innovations at the intersection of science and design. For example, researchers from the RCA and Huawei have explored ways in which identity, experience, and products are shaped by human perceptions, behaviors, and interactions. And here, the Healthcare Coach of the Future explores trends affecting personal healthcare assistance via mobile communication. The RCA's Helen Hamlin Centre for Design, which focuses on inclusive design, has been working with the team at King's College London and the NHS Maudsley Foundation Trust to develop an app as part of a project exploring how to provide support as part of daily life to people with mental health challenges. So to conclude, useful design-led innovation can be greatly enhanced by creating an appropriate environment, developing strategies, talent, structures, and partnerships, placing design not at the end, but at the forefront of the innovation process, and asking human-centered questions. As home to one of the UK's most successful incubators, Innovation RCA, the Royal College of Art plays a significant role in developing this talent which has led to any number of useful innovations addressing real-world need. And it's quite likely that the disruptors of today will be the leaders of tomorrow. We've only to look at the largest global companies today. They mostly did not exist 30 or 40 years ago. So to get there, design-led innovation and principles need to happen from the outset and not be bolted on at the end. One way of doing this is to bring wider audiences is through our innovation education program, which delivers senior-level custom executive education programs for business, government, and the public sector. And just two final examples. Real wonderful examples I can't finish without touching on here. Incredible innovations. ZELP, Zero Emissions Livestock Project. Methane from the 1.5 billion cows that make up the beef and dairy industries are major contributors to global warming, emitting the carbon equivalent of more than the whole of the transport industry put together. Methane is 85 times worse for global warming than carbon dioxide, and demand for beef and dairy products is expected to almost double in the coming decades. But did you know that 90% of the methane released by cows is released through their mouths? What can be done? ZELP's wearable product converts methane into CO2 and water. It also captures data on herd efficiency as well. This company began as a project during Francisco Norris's MA at the RCA, and since incubation has already raised over £1 million and partnered with Europe's largest animal producer. And finally, London Forest Products. This has patented a process to 3D print pure carbon. 3D printed pure carbon would have applications as medical implants. For example, carbon has great biocompatibility and has a similar tensile strength as bone. And so it would result in less muscle attrition than titanium-based 3D printed implants. And in the aerospace and automotive sectors, because pure carbon is strong and lightweight and has a 5,500 degree melting point. This was founded by Patrick Morris, who became very interested in natural fossilized materials during his MA at the RCA. And this company is just starting up, but has already garnered international collaborators and won a £100,000 Innovate UK grant. So thank you once more for your kind invitation to speak here at the Designing Future Textile International Symposium. And I look forward to further discussion about how design and technology can create innovation for the benefit of society, and to seeing some excellent examples of design innovation. Thank you very much.
Absolutely mind-blowing. Thank you very much, Professor Barfield from Royal College of Arts.